In Lesson 9, we're going to be introduced to ratio tables. So for the first example, it says to make paper mache, the art teacher mixes water and flour. For every 2 cups of water, she needs to mix in 3 cups of flour to make the paste. So I'm seeing ratio words. For every 2 cups of water, there's 3 cups of flour. Find equivalent ratios for the ratio relationship 2 cups of water to 3 cups of flour. Represent the equivalent ratios in the table below. So for the first row, what we're going to put in is 2 cups of water to 3 cups of flour, just what the example tells us. We are then going to find the value of this ratio. So it's a 2 to 3 ratio, which we would write as a fraction if we're finding its value, and then put it in simplest form. 2 and 3 do not have a common factor besides 1, so that would be the value of the ratio, 2/3. If we wanted to continue to make a new batch or more of the same batch of paper mache, we would have to keep the ratio the same so it would stay the right consistency. So each batch should have 2 cups of water and 3 cups of flour. So if I wanted to make more, I would have to put in another 2 cups of water and another 3 cups of flour. So for my next batch, I would have to have 1, 2, 3, 4 cups of water for 1, 2, 3, 4, 5, 6 cups of water. So the ratio is now 4 to 6. The value of this ratio, I would take the 4 to 6 and write it as a fraction, and then I would put it into simplest form. 4 and 6 can both be divided by 2, so this would become 2/3. Notice the ratios have the same value. Since they have the same value, we say they're equivalent ratios. In a ratio table, all of our ratios will be equivalent to one another, and they'll have the same value. So if we continue on with our ratio table, if I wanted to continue to make more, I would have to add another 2 cups of water for another 3 cups of flour. If we count total, we have 2, 4, 6 cups of water and 3, 6, 9 cups of flour. To find the value, I write that as a fraction, 6/9, and put it in simplest form. 6 divided by 3 is 2, and 9 divided by 3 is 3 to get the value 2/3. Again, all of the ratios in this table have the same value. If I wanted to make more, another 2 cups of water, 3 cups of flour. For water, I now have 2, 4, 6, 8 cups of water, 3, 6, 9, 12 cups of flour. For the value, 8/12, both can be divided by 4 to create that value of 2/3. In the final row in my table, I will do another 2 cups of water and 3 cups of flour. So now we have 2, 4, 6, 8, 10 cups of water, 3, 6, 9, 12, 15 cups of flour. For the value, 10/15, both can be divided by 5, which gives us 2/3. Same value for all of the ratios in the table. So we would say the value of the table is 2/3. So some important things to realize about a ratio table is, as we said, all of the ratios in the table have the same value. In this case, they all were equivalent to 2/3. Another thing that's important to notice is if your first ratio in the table is in fact the value as a fraction, so if I were to turn this ratio into a fraction, it becomes the 2/3, which is the value of the table. What that means is I can just see what I'm counting by down each column. So since this is starting with 2 in the water column, I'm just counting by 2s as I go down. In my flour column, I'm counting by 3s. So just something to look at with the construction of a ratio table. So now that we know how this table is built and what the value of this table is, I'm going to answer some questions based on the information in the table. So question B says the teacher has 6 cups of water. How much flour should she add to the mix? So what I can do is just go up to the table, find 6 cups of water, and see how many cups of flour would match up with it. So 6 cups of water matches up with 9 cups of flour. So my answer would be 9 cups. The next one says the teacher has 24 cups of water. How much flour should she add to the mix? Now what's interesting with this one is that we do not have 24 cups of water in the table. So there's a couple of different ways we can do this. The first way that we could do this is to continue on the table counting by 2s down the cups of water column till we got to 24 and seeing what it matches up with for flour. That's kind of a lot of work, so what I'm going to recommend is using the value of the ratio to find the missing number. So we know the value is 2/3, with 2 representing the number of water and 3 representing the number of flour. So if I know I have 24 cups of water, I would just need to find an equivalent fraction where 24 would be across from the 2 for water. So in order to do this, I know that 2 times 12 is 24. So 3 times 12 would give me my answer of 36 cups of flour. Again, just making sure that we're multiplying our numerator and our denominator by the same number to create that equivalent fraction. Okay, so again, this goes back to the fact that all of these ratios in the table, when simplified, have that same value. So 24/36, when simplified, would be 2/3. So it would make sense for that to be in our table. Laura needs to make as much paper mache as she can. She only has 5 cups of water in her classroom and doesn't have the time to get more before her next class begins. How much flour does she need to make the biggest batch possible with the water that she has? So this one's a little different. The value is 2/3 water over flour, of course. We only have 5 cups of water and we're trying to make the biggest batch. So we want to use all of that 5 cups of water. So in this case, what's going to happen is we are going to end up figuring out that there's going to be a decimal involved, which is quite all right when we're doing a ratio table like this. And we're going to see this quite often. Math tools. I'm going to use my calculator so you can see how this works. If I don't know what 2 times what number it is that I'm multiplying by, what I can do is divide. So I'm going to divide 5 by 2, and when I do that, I get 2.5. So what that's saying is 2 times 2.5 gives me that 5. Since I multiplied my numerator by 2.5, I'm going to multiply my denominator by 2.5 as well. And I wind up with 7.5 cups of flour. And 7.5 and 7.5 are the same thing, so you could either have 7.5 cups or you could have 7.5 cups. Those are the same thing. Just a little caution about when you're putting mixed numbers into the computer. So if I have 7.5 and that's the answer I want to use, I can use 7.5 and just put it in as 7.5. But if I did want to put in 7.5, what I would do is I would put my 7 down, I would leave a space, and then I would put 1/2 to make that fraction 1/2, which you should be familiar with seeing. But the important piece is to have that space in between the 7 and the 1. Because if we don't, it's going to look like 71 halves, which is a totally different number. Okay, so this was our little introduction to the ratio tables here. And now we're going to look at a different problem. So what this problem is doing is having us, let me move my calculator out of the way, having us fill out the table below using the value of a ratio. So the first thing I notice is that I do have two numbers filled in on both sides in this row right here, the 27 and the 45. So that's where I'm going to start. I'm going to use the two numbers I have in a ratio to find the value of the table. So remember, to find the value, you take a ratio, write it as a fraction, and put that fraction in simplest form. So looking at 27 and 45, I can see they can both be divided by 9. When I divide both of these by 9, I'm going to see that 27 divided by 9 is 3, and 45 divided by 9 is 5. So the value of this table is 3/5. So what that means is every single ratio in this table, when simplified, should equal 3/5. So to fill it out, what you may want to do is figure out your numerator and denominator maybe for a title for each of the columns. That way you can match up. 3 is my numerator, obviously, 5 is my denominator. So I'm going to use that to make equivalent fractions. So the first one that I see set up here is my 18. So my 18 is the first number in the left-hand column, or my numerator. I don't know the denominator that matches up with it, so I'm going to put that as a denominator blank space. I don't know this number yet, but I know that this is going to equal 3/5. So what I'm going to do is I'm going to see that 3 times 6, and I just write it to the right, it doesn't matter, gives me 18. So to find the matchup for the 5, I would do 5 times 6, which would give me 30. So over here, I would put 30. Now some of you may already be able to tell what you're counting by on this side or on this side and be able to fill out the other numbers that way. But we're going to look at using the value still. So the other place I see a number is right here, and that's in my denominator. I don't know the numerator, but I know that it should simplify down to 3/5. So what I would have to do here is see what I'm multiplying 5 by to get 60. Now, if you didn't know what that was, you could use your calculator and do 60 divided by 5, which is 12. So I'm doing 5 times 12 to get that 60, which means I need to do 3 times 12 to get my numerator, which would be 36. Now, I know that to go from 18 to 27 and 27 to 36, I should be counting by the same number. Just as we discussed on the first page, remember in the first column we were counting by 3s? So we can figure out what we're counting by subtracting any two of those numbers. So let's say I do 27 minus 18. That shows me the number that should come before it, before the 18, should be 9 less than 18. And 18 minus 9 is 9. I am then adding 9 as I go through my table. So 9 plus 9 got me 18. 18 plus 9 got me the 27. 27 plus 9 gets me the 36. And then I can do 36 plus 9 to get my final number, which would be 45. Now to figure out the other side, in the denominator column here, we can do the same method, subtract the two, see what we're counting by, and continue that way. Or we can continue using the value of the ratio. I'm going to go with the value of the ratio for this piece. I know my first numerator here is 9. I don't know the denominator, but I know that it should become 3/5. So to go from 3 to 9, or 9 to 3, depending on which way you're looking at it, I'm going to go from 3 to 9. I would multiply by 3. which means I want to multiply my 5 by 3 as well, which would tell me it's 15. Now once again, we can use our value for the last one here to see what it would be, or we can also do that subtraction method that we used over here. So for that last piece, I'm going to show you that way. So I would do 30 minus 15 and see that it's 15. So that just means as I'm going up, I'm adding 15. And if you think about it, 30 plus 15 is 45. 45 plus 15 is in fact 60. And 60 plus 15 would give me my final answer of 75. You can check it just to be sure, to make sure that it does simplify to 3/5 for each one of these. But the adding method does work as well as you go down the column. Okay, so you guys have some practice problems that you can work on. Go ahead and get started on those, and good luck.